Hi team, Mr. Rato here. Okay, we're going on to quadratic inequalities part 2. So here it goes. A ball is thrown upwards and its height is h at time t seconds, so height in meters, t in seconds, time in seconds. It is given that h is equal to 70 minus 4.9 t squared. How long does the ball spend? How long does the ball spend? Spend more than 1.5 meters above ground level. Okay, so first of all, we need to rewrite this. We need to say when is the height, which is 7t minus 4.9 t squared above 1.5. Okay, so I'm going to bring everything to one side. So let's just keep this inequality the same. And this is minus 4.9 t squared. I always like to have the t squareds positive or the x squared positive, so having a positive quadratic equation. So we say bring that to the side becomes plus 4.9 t squared. Take the 7 plus the 7 to the other side becomes a minus 7t, and this is already a positive, which is plus 1.5, and there's nothing left on here, so that's 0. Now you've got a calculator. If you plug these values in the calculator, you'll get t equals to, the roots will be, now to 3 significant figures, that will be 1.17. Well, this is 3 decimal places, 1.167, and the other root you're going to get is t is going to be 0.263. Right, so what that means is, if I do a quick sketch of this graph, t is there, 0.263, and there 1.167, and it's a positive, so it's a smiley face. Okay, so the quadratic in that shape, parabola going up and down. So when is this graph less than 0? So let's just choose the graph here. So it's for all the values when it's less than 0 between there and there. So when t is less than 1.167 seconds, t is between 0.263. So what this means is, so if I was chucking the ball up, throwing the ball up, the ball is thrown up, goes to a maximum height, then it returns on itself as a parabola shape. So if we think about here, okay, so this being height 1.5 meters. So at this point, the ball is above 1.5 meters, and it continues above, and then on its return journey, that's when it comes back down. So at this point of time, 0.263, the ball is in flight and it's above 1.5, and then at this point it comes back down 1.167. Okay, so how long does the ball spend? How long does the ball spend more than 1.5 meters above the ground? So it's the time it spends is going to be t equals 1.167 minus 0.263, which is going to give us 1.167 minus 0.263 is going to be 0.904 seconds. So 0.904 seconds it spends above the ground, 1.5 meters above the ground. Okay, let's go on the next one. Right, solve these inequalities. Okay, let's just go for the first one. They look pretty standard. I 7x minus 5 less than 3x plus 5. Okay, so I'm going to bring all the x's to the side which has got the most on. Just like solving equations, I'm going to take the 3x to the other side, which becomes minus 3x. So 7x minus 3x is going to give me 4x. And I've got minus 5 here. So this is going to the side, so I've got 5 still here. So this one goes to that side, so that's going to be opposite of minus 5 becomes plus 5. So that's going to be 4x is less than 5 plus 5 is 10. So x is going to be less than 10. Focuses by dividing, which is same as 5 over 2. So x is going to be less than 5 over 2. And part 2, got this equation. So again, I'm going to do what we've done before, bring everything to one side. So x squared minus 7x. I'm going to take the 4x to the other side. I did it inverse. Opposite of plus 4x is minus 4x. Opposite of minus 5 is plus 5. And the inequality stays at 0. So there's nothing left on the right hand side. So I've taken everything on the left hand side. So I end up with 2x squared minus 11x plus 5 is less than 0. And we can factorize this because we've got 1 and 5. Double 5 is 10 plus 1 is 11. So this is factorizable. We can put 2x in the first bracket, x in the second. I'm going to double the 5, so that's going to go there, the 1, and they're both going to be the same symbol, both minuses. Let's just operate. 2x times x is 2x squared, minus 10x, minus x is minus 11x, plus 5. Okay, so that gives me roots of x equals 5, and I've got here x would equal 1 over 2.5. So if I was to sketch a quick diagram, there's a half, there's a 5, there's a positive graph, so it goes like this, come back up, half, 5, and we want to know when it's the graph below that. So this is when it's below, so this is when x is less than 5, greater than a half. Okay, so less than 5, greater than a half satisfies that inequality. Okay, so hence find the set of values of x for which both equation, first part of the equation, inequality, and the second part of the equation are satisfied. So x has to satisfy both of them. So x, so in this case, it can't be, it has to have its top limit as 5.5, and x for this one has to be greater than a half. So to satisfy both inequalities, part B, x would have to be less than 5 over 2, less than 2.5, and greater than a half, which will satisfy both of them. So x value there will satisfy that, and will also satisfy that. Okay, right, it's like simultaneous ways of doing this. Okay, talking about simultaneous equations, inequalities. So what we do is, like we did in the previous question, we solve this inequality, and see which one will satisfy, what will be the value of x that satisfies both of them. So first of all, we take everything to that side, so I'll get x squared. I'm going to call this number equation inequality 1, inequality 2. So for 1, we got to get 5x equal to, so it becomes a minus 5x plus 6 is greater than 0. So if we factorize that quickly, that's easily done. X in each corner, it's going to be 3 and 2, doesn't matter which way around, both negative, greater than 0. So if I do a quick sketch here, so 2 and 3, positive, so it's going to be 2 and it's going to be 3. So in this case, we want everything that is above 0. So x can be less than 2, and x can be greater than 3. We want everything above here and everything below that, since that's when the curve is above the y. Okay, above the 0 line. Okay, let's do number 2. So let's have a look at number 2. Similarly, bring everything to one side, so you get x squared minus 1 is greater than or equal to 0. So that's just difference between two squares. We can factorize that by putting x plus 1 and then x minus 1 is greater than or equal to 0. Again, if we do a quick sketch, we got 1 and minus 1. It's a positive quadratic, so we go up and down. So this point is 1. This point is minus 1. We want everything which is above or equal to. So we want everything that's equal to 1 or above, less than 1 or above. So x, in this case, x can be greater than or equal to 1, or x can be less than or equal to minus 1. Okay, now we're going to simultaneously do this. Which one will satisfy these points? So first of all, let's look at the end line 2, less than 2. X is less than minus 1, that's the lowest point here. So we can have that inequality. We can say x is less than or equal to minus 1, because that will satisfy this and it will satisfy that. Minus 1 is less than 2, so we're okay with that. Now, we also got a point where x could be greater than minus 1 but less than 2. So we could have inequality less than 2. So it goes less than 2. But it's got less than 2, but it's going to be greater than or equal to 1. So it can be greater than or equal to 1. So that will also satisfy any number which is greater than 1 and it's less than 2. 2 is about here. Let's just plug actually, if we put the 2 there and we put the 3 there, so that this region here would also satisfy region. So when x is less than 2 and greater than or equal to 1. Okay, so that will satisfy the inequality. And now greater than 3, yeah, that will just satisfy all the both inequalities. X is greater than 3, so greater than 3 will satisfy that, and 3 is greater than 1, so it will satisfy that. So we have the three inequalities. These three inequalities will satisfy those two. Okay. Yeah. Okay, so let's look at this. Find the range of values of x for which both of these inequalities are satisfied. So this is very similar. If you want to pause it and have a go, very similar to one that we just done. We'll bring all the x's to one side, so I'll get 2x squared minus 4x is greater than equal to 0. So again, I'm going to call this equation 1 and call this 2. So let's just quickly factorize this. So 2x is both of them, x goes there, minus 2. So that will be 2x squared minus 4x, yep. And if I was to plot this, x will be 0 and x will be 1. The graph will look like this. I've got 0 there, and I've got 2 here. And when is the graph above line 0? It's when it's equal to 2 or equal to 0 and there. So x is when x is greater than or equal to 2, or we got when x is less than or equal to 0. So that will satisfy that. Now looking at this again, let's just go and try to factorize this. So we've got 5x squared minus 13x minus 6 less than or equal to 0. Again, you can do this on your calculators if you wish. I'm thinking 1, 6. No, that's not going to do it. 2, 3. So I'm going to get 15 and then take away 2 is 13. Yeah. So if I put 5x in this corner, x here, so I'm going to times that by 3. Put the 2 there, so that's going to give me negative. That's going to be positive. That's less than or equal to 0. Let's just double check this. 5x times x is 5x squared. That's going to give me minus 15x plus 2x minus 13. Yeah, so that's factorized. And we'll get the roots where we've got x is equal to 3 here, and 5x equals minus 2. So x equals minus 2 over 5. Okay, and if I quickly just sketch the graph along here, I've got the roots 3, and I've got this root here, minus 2/5. Again, it's a positive graph, so smiley face goes up and down. And this time I want all the inequalities which are below this line and satisfying the points, so all this to be satisfied. So in this case, x has to be less than or equal to 3, greater than or equal to minus 2/5. Now we have been told to kind of do these equations simultaneously, so we'll satisfy both of them. So let's just have a quick look here. So x is going to be less than 0, which is going to be has to be greater than. So we can have an inequality where we got where x is greater than or equal to minus 2 over 5 and less than greater than or equal to 0. So that inequality will hold. So that will satisfy both of these. So there it goes. And the other quality, so this has to be greater than 2 but less than 3. So we can also have the inequality where x is greater than or equal to 2, satisfying that, and at the same time satisfying this will be less than or equal to 3. So you will have these two inequalities which will satisfy, so these are the ranges or values of x which will satisfy both inequalities.